Yeah, so I think we are ready to begin. If you're ready. So yeah, today's topic,
Yes.
yeah, power, Ohm's law, and electric circuits. And this will be the last part of our physics lesson. I mean, this is the third part of our physics lesson. There will be one more section after this. But today we will learn about what power is. We'll learn about voltage, current, and resistance. We'll learn about the Ohm's law. We'll learn about the electric circuit and symbols. We'll learn about series circuit and parallel circuits, so different types of circuits, and capacitor and transistors. Okay. So what is power? Power is the rate at which work is done. So power means how fast work is done and how fast you can use energy. So the units are called watt, the capital W, and this is just joules per second. So that's because power is work over time. That's why its units are joules per second. I will show you the equation in the next slide. But there are two main types of power that you need to know. It's the work power and the electrical power. So work power was the equation that I was talking about in the previous slide. So work power means how fast you do work. So it is power equals work over time. So remember that P equals W over T. So that is the equation for calculating power. And this makes sense because you need to know how fast you're doing work. And when you divide work by time, you're calculating the rate. So an example of power is imagine you're lifting a stone or a dumbbell and you use energy to lift it. Well, change in energy is also called work. Right? So if you lift a stone in 10 seconds, but your friend lifts the same stone in 1 second, then your friend uses more power because it is the same rock applying the same work, but it's just in a less time. So I will show you this video, and this video will explain the basic concept of power. It's going to be a few seconds long. Okay, yeah, that was a brief introduction to work power. So we could see that power is basically measuring how fast you do work. There needs to be a way to separate um, the same work done at a different rate. So how fast you do work is also important. Okay, so let's solve a problem together. A machine lifts a load of 100 Newton through a vertical distance of 2 meters in 10 seconds. What is the power of the machine? So this might be a little difficult, but if you think about it, remember P equals work over time, W over T, right? So this is the equation. But we are not given work explicitly here. So we need to calculate work, right? So work needs to be force times distance, I put here. So
D.
what is work? Sorry, D. Did you say D?
D.
Okay, let's see. So yeah, let me see. So if you have force times distance, you get 100 times 2, which gets 200 of work, right? But if you said D 2 watts, then I think it might be a little too less, right? Because work is 200 that was done. So what is 200 over 10 seconds here? It says 10 seconds as time.
B. B.
Yes, that is right. The answer is B in this case, because I put the work here. So work is force times distance, 100 times 2, which is 200. And power is W divided by T, work over time. So it's 200 divided by 10, which is 20 watt. So that's how you calculate the power in these questions. Let's look at another example, and I will share you the slides so that you can look at it later as well. But okay, so first question, define the term power. So does anyone want to do that?
Power is the rate at which work is done.
Yeah, that is right. You said it perfectly. Power is the rate of doing work. Yeah, how fast the energy is used. They're the same definition. Okay, so number 2. If a machine hauls a packing case of mass 50 kilogram up a building that is 10-meter high in 30 seconds, calculate the power of the machine. So for this one, it's a little bit more difficult than the last one because we need to calculate the force first, right? 정답 나오지. Yes, so I will help you get started. So remember that work, we need to find the work, right? Time is given to be 30 seconds. So time t equals 30. Okay, that is good. Check. But we don't know what work is here. To calculate work, we know work is force times distance, right? We covered that in our last lesson. But remember always that work is force times distance. How much force is acted on a distance is called work. Now, distance is given. It's 10 meters. Since you are hauling up 10 meters, the total distance is 10 meters. That's D. But what is F? What is force in this equation? So force is, remember, what is force equation? Force equals ma, m times a. This is Newton's second law from our last week, right? So this is Newton's second law. That's how you find force. And since this machine is acted against gravity, A is equal to 10. So it's given here. Look at this. G. So this is gravitational acceleration. So this is how much an object accelerates when it is in free fall. So we have mass, which is 50 times 10, and we get 500 Newton of force. Okay, do you guys think you can solve the problem now? We have force equals 500. Force times distance. Okay. Work is equal to, I'll help you out a little more, 500 times 10, which is the distance, 5,000. So what is power? So what is power now? Can you guys solve it? Work is 5,000, time is 30. So you don't need to be exact, but 엄마, 엄마 일로 와봐. 5,000 나누기 30이 어떻게 60이요? 166점.
5,450 하는 게 30이라고.
So this says 5,000 over 30. It's actually not 60. You can just say it's 500 over 30, over 3, sorry, which is around 167 watts. So that is the final solution. So I hope that you can get how to solve this problem of power. Um,
Yes.
yeah, please let me know if you have any questions at the moment, and I'm happy to answer them. Uh, So, do you think you know how to solve this problem?
Maybe
Okay. Yeah, always feel free to ask me any questions if you're confused. But this is how you calculate power. You calculate the work, divide by time. Okay. Okay, then let's move on to a second category of power, and this is electrical power. So we will focus a lot of electrical power too in this lesson. So power applies the same with electricity. So when a device uses electrical energy, electrical power means how fast electrical energy is used. But in electricity, we have a different equation. Although it is the same concept of work over time, remember, power used in mechanical was used to be work over time. But in electricity, you can also calculate power by voltage times current. So another equation for power, strictly for electrical purposes, is P equals voltage times current. Just So work power and electrical power looks different. It looks this and this equation is different, right? But they are essentially the same thing. So for example, a 100-watt light bulb uses 100 joules of energy every second. So it's still a watt, which is joules per second, work per second. So they're saying the same thing, but with a different equation. Okay, let's see how electrical power applies here. So this is a simple problem. So an electric bulb is rated 0.5 ampere, and ampere here is the unit of current. And it is also rated 120 volts. Determine the power produced by the bulb when it is turned on.
B. B.
Yes, that is correct. Yeah, simply what you have to do. Yeah, B is right. 120 multiplied by 0.5, which
Quanto
equals
errado?
60.
Sento. Eu não tô devendo.
Yeah, great job. That's how you solve it. 120 is the voltage, 0.5 is the current. So multiply those, you get the power of 60 watts. Okay, let's look at the next question. Okay, so an electrical engineer was in your school to replace a 20-watt bulb with a 50-watt bulb. So you're changing it. Use this information to answer the question below. So the 50-watt bulb that has been changed is likely to, is it one, increase the brightness of the room, two, increase the amount of electricity consumed, three, destroy the habitat of pests.
B.
So yeah, let's look at B. It says 1 and 3 only. So 1, increase the brightness of the room. That is right because it has more power. It is brighter. But 3, I don't think it really destroys the habitat of pests. Um, but rather here, yeah, the answer would be D. If you said D, that is correct. Um, so it's 1 and 2 only. It increases the brightness and increases the amount of energy consumed, amount of electrical energy. Okay. Okay, let's calculate this um this problem. So an electrical appliance in the house uses 4,000 watts of electric power every 12 hours. Calculate the energy used within this time. So remember that power is work over time. And remember, work is same as change of energy. So you can replace by energy here. And calculate energy by power times time. So can anyone do that? What would be the answer here for energy?
No, it's time.
Okay. Let me say.
Yeah,
What? Wait. Lighting.
Yeah, I heard the answer. That's right. Yeah, it's 48,000. Yeah, I heard. Yeah, you're right. It's 48,000 watt hour, or you can also put it as 48 K watt hour. It's the same. So yeah, great job. So multiply 4,000 of power times 12 hour, which is time, and you get the energy. Okay. Now let's all look at this new concept called the LED. So what is LED? LED is, well, it's a light emitting diode. That's the name. And it is a small electronic device that gives off light when electricity passes through it. So when an electric current flows through the LED, it flows through it, all the electrical energy. It glows. So the LED glows, and it glows very efficiently. So the LED does not get very hot, and it uses very little energy to make light. And it lasts a long time compared to normal light bulbs. So you can see that it uses less energy. It is very efficient in emitting light. So that's why it lasts longer. So actually, a standard bulb produces light by heating a thin filament inside a regular bulb. But light is not produced by heating here. It's just a direct glow from the electric current flow for the LED. Let's look at where LED is used. So LED is used in many cases. In phone screens, flashlights, TV screens, traffic lights, car headlights, even some home lighting, and there are many uses of LED because it's really efficient in emitting light. Okay. So I have just put the answers here for this one because the LED is an electronic device that produces light when current passes through it. And we have already covered this. Two devices examples are like TVs, smartphones, computer monitors, and more. All use LEDs. I think we can skip this one, but I hope you get what an LED is. How
Yes.
LED is used. Okay, great. Now I'm introducing to you another very important topic. It's about electricity, especially about the voltage, current, and the resistance. So you'll learn about how electric current is formed, usually by a battery, and what voltage, current, and resistor plays a role in that electric current. So let's watch this video. Okay, so we'll look at it until here. So basically what we've seen is that over here, electricity is flowing this way. You can see in the picture that there is a high concentration of electrons on the right side, but no on the left side. But notice that it's not just going through this way. This cannot happen. So that's why you need to connect a wire that helps electrons go this way to this side. So it's going this way. And it's being filled up. And once there's no more energy to move this electron to the right side, then the battery has been drained out. Okay. That was what the video talked about. So we looked at two main things, and I'm going to add another concept called the resistance, but we've seen what a potential difference is. And potential difference is also called voltage. So definition, it is the amount of electric energy transferred between 2 points in a circuit. So the voltage is what pushes electric charges to move. We also have the current. So the definition of a current is the flow of electric charge in a circuit. So this is the flow that is going past maybe some light bulb or the wires. That is the measure of the flow, is the current. And finally, there's the resistance. So the definition of resistance is the opposition of the flow of electric current. So the resistance is stopping or hindering the current to flow. So anything that slows down the flow of electricity. And the unit is in ohms. And remember, current unit is ampere. Voltage unit is volt. And I think a really good analogy is the picture on the right here. You look at this picture, the potential there, the voltage, the yellow guy is pushing the green guy across. So this is overcoming the potential difference by pushing the current to the right. And the current is being passed through. And then the resistance up here is opposing the flow, is restraining the flow from going through. So I think it's a really good image showing all three of these. And now we get into Ohm's law. So Ohm's law says that the amount of electric current in a circuit depends on the voltage and resistance. So it's given by V equals I times R. This is another equation that we have. So voltage V is the potential difference, and that's equal to the current times the resistance. So more current means, more voltage means there will be more current because current is directly proportional to voltage. So it makes sense because if you push it harder, then there will be a faster and more current, right? On the other hand, if there are more resistance, there will be less current. And this makes sense because if we can also write this as I equals V over R by rearranging. It's the same equation. You can see that if there are more resistance, then it'll be harder for electric currents to flow, electrons to flow. That is why there will be less current if there are more resistance. But anyways, let's look at this short video, and this explains really well how Ohm's law works. So it has an analogy of a water tank, and you'll understand the concept of what Ohm's law does. So here is the video.
To stay off the naughty list.
So yes, that was the video about Ohm's law, and this showed, how Ohm's law can be represented by a water tank. And you can see that the more current, the more voltage, V, is equal to putting a lot of height to the water tank. So it is allowing to push the current more. So this will lead to more current, and more resistance will lead to less current because you're restricting the flow, right? Yeah, so here is an example. So I want all of you to see how this is happening. So here we have one battery on the left. This battery has 3 volts, and it lights this much light bulb. So light bulb emits this much light. That is with 3 voltage. But with more voltage, we have 2 batteries on the right. 2 3 volts. So we have 6 volts. V equals 6 volts. So this has more voltage. And remember, V equals I times R, or I equals V over R. It's the same. So if we have more voltage, what happens to the current? It increases, right? It gets bigger. As V gets bigger, I gets bigger. So that is why this has more current and lights up a brighter light bulb. So it's brighter, the light bulb. Since we have 2 batteries instead of 1. Same with resistance here. Here again, I equals V over R. So let's look at the resistance changes from the picture on the left to the picture on the right. On the left, this is the resistor, so there is only one resistor, so it'll be like 1 R, for example. But on the right, there are 4 resistors. There's a large amount of resistance to the current, so there will be less current. And this light bulb actually is a way to represent the current. So if there's more current, the light bulb will glow brighter. But I just wanted to let you know that if there is more voltage, then there is more current. If there is more resistance, there will be less current. Okay, let's move on to this question. So let's solve this question together. So the current in a resistor is 3 ampere. The resistance of the resistor is 4 ohms. Determine the potential difference across the resistor. And potential difference here is the voltage. So can anyone calculate the voltage for this question? What is the voltage?
D.
Yes, I think I heard D, and that is correct. So yeah, this is 12 because it is 3 amperes, which is the current, times 4 ohms. And according to Ohm's law, this should equal voltage, V. That is 12 volts here. Yeah, great job. Let's also look at this next question. This is similar. So the current flowing through the resistor of resistance 10 ohms is 2.5 ampere. What is the potential difference between the 2 terminals? The resistor. So this is the same question with different numbers.
A. A.
I think I heard A, but the answer is actually C because you see here, the resistance is 10 ohms. And what is the current? The current is 2.5 ampere. So remember, we're multiplying 2.5, which is the current, times 10. 10 is the resistance, 2.5 is the current. So current times resistance, this should be 25, right? 25 volt. That's why the answer is C, 25 volts. Okay, so that's how you calculate the potential difference, also known as the voltage. Okay. Now let's look at some of these sets of questions. So this is a little different type of question, but I think you should be able to solve this. So if you look at A, let's look at this diagram at the top. So this one. So if we look at this one, we're given the voltage of 18 volts. We're also given the resistance of 6 ohms. So can anyone calculate the current I for this circuit?
Voltage over resistance.
Can you repeat that, please?
Voltage over resistance.
We're calculating the current, the I for A. So resistance here is given as 6 and voltage is given as 18. You can see it here. So voltage is 18, resistance is 6 ohms.
The answer is 3.
Yes, that is right. We use this middle equation. Yeah. I equals V over R. So 18 divided by 6 equals 3. Ampere is the unit. 3 ampere. And let's look at B, the second one. So in this case, we are given the current as 1. And we're given the resistance of 13. Calculate the voltage of this circuit.
13. 13.
Oh, yes, that is correct. Yeah, great job. It's 13 because in this case, we're using V equals I times R. And current I is 1. R resistance is 13. So we have voltage equals 13 volts. Yeah, great job. Let's look at this final question. C. So we have voltage equals 8.
2.
Yeah. Oh, did you say
2?
Yes. So yeah, great job. So this will be 2 ohms. Yeah, nice job because it is 8 over 4. That is the resistance. So voltage 8 over I, which is 4. Get 2. And the unit is in ohms. Okay. Yeah, it seems like all of you are pretty good at solving this. So let's move on to the next question. So can anyone answer this first question? So explain and define the term potential difference, the voltage. Does anyone remember? I can go back a few slides if you want. Yes.
Is the amount of electric energy transferred between 2 points in a circuit?
Oh, yes, that is right. Yeah, that's the definition of potential difference. So it is the amount of electrical energy transferred between 2 points in a circuit. So remember that a battery has 2 sides. It's the positive and the negative side. So to move from small amount of electricity as it fills up to this large amount, we need voltage. We need voltage to push the electrons across. So it is the amount of energy that is transferred between these 2 points in the circuit. So yeah, great job. Let's look at the second question. The potential difference across the terminals of a 100 ohm resistor is 200 volts. Can you calculate the current I?
Karen.
Give me 2.5 ampere.
Let me see. Okay, so that is right. It's 2.5 ampere. You got it right because remember the current is V over R, and V is given by 250, and R resistance is 100 ohms. So 200 volt divided by 100 ohm is 2.5 ampere for the current. Yeah, great job. I think you're really good at solving these questions now. Okay. So now, now let's move on to the concept of electric circuit. So before we talked about some of the properties, talked about the voltage, current, resistance. But the whole thing forms a circuit. So electric circuit is a pathway that electricity can flow through. So it is just a connection. For electricity to move, the path must be closed, like a complete loop. And electric current circuit components are things like battery, wires, light bulbs, switch, resistor, etc. So you can see that this whole thing is called a circuit. And if the switch is turned off, then the circuit is disconnected, so it's not working. Okay. So just remember that electric circuit is the pathway that electricity flows through. Okay. Here, I have some pictures, and these are just some examples of symbols of electric circuits. So you don't have to like really memorize all of them, but it's good to be familiar with some of these symbols and drawings.
Okay.
So yeah, A just stands for ammeter, and ammeter is what's used to calculate or determine the current in amperes. This thing, the pink, or it's not really in pink, but this shape is called a cell. It's the battery. Um, Specifically, well, the battery has two cells. So this is a battery. This is just one cell. And this thing is called a diode.
Oh.
This two line is called a capacitor. This box-like thing is called a fuse. This X cross with a circle is a lamp. This is a resistor, or resistor can also look like this, like a zigzag. And then things like the switches look like this, the switch that is open or closed. And we also have things like voltmeter and motor. It's in V and M, like this. Okay, it's just a small introduction of symbols, but let's see here that the symbols are in action. So can you identify the symbols here? So here we have 3 batteries. How do you show that in the circuit symbol? We have this. This shows 3 cells, 3 battery. The battery of 3 cells. Okay, and we have the resistor over here. And it is shown like this in the diagram. Resistor is a zigzag, this spiky part. Okay. And then we have the light bulb here in the middle. And the light bulb is represented like this in the diagram. And finally, we have the switch. Switch looks like this, sort of, in real life. But in a diagram, it's represented like this, the switch. So you can see how the electric current circuit can be drawn. Okay, so yeah, here are just some examples of what the symbols. So the BECE physics question might ask you to draw some of the symbols, and you'll need to know maybe just some of them, but I wouldn't really be too scared. Just know what to look for in the diagram if you have to. Let's look at now about different types of circuits. So we have the series circuit and the parallel circuit. These are 2 different circuits. So series circuit has only one path for the electric current. So it all flows through this one path of a circuit. All components are connected one after another like a chain. So it's not split anywhere. It is just one path. Okay, there's also a different type of circuit called the parallel circuit. And in a parallel circuit, it has more than one path for the current. And the components are connected on a separate branch. So you can see here that the light bulb is connected in a 3-way branch over here. Okay, so that's the difference between series and parallel. Series all in one circuit, one path. Parallel branching off. Okay. So when you're finding the resistance in the series circuit, you simply just add the resistor resistance. So, yeah, everyone, if you look at this picture, we can see that the resistors are in series. Yeah, everyone see this picture on the right? The resistors are in a series. Why? It's because they are aligned, all in the same path. That's why it's in a series. But resistance in a series, you add R1, R2, R3. So if each of the 3 resistors have 10 ohms, the total resistance would be 10 plus 10 plus 10, which is 30. So this circuit has a resistance of 30 ohms total because the resistance is in a series next to each other. But now things get a little bit complicated when you put resistors in parallel. So if you put the resistance in parallel circuit, then it is calculated by this equation right here. So basically, you're taking the inverse, sort of, the reverse, the reciprocal of R total by adding the denominator. It's a fraction now. But what this tells us is that if you have, like 10 ohms resistors in parallel, it's just 1 over 10 plus 1 over 10 plus 1 over 10, which is 3 over 10. That is 1 over our total. So the total resistance, if you flip this, would be 10 over 3, or 3.3 ohms. That's how you calculate the resistance in a parallel circuit. But notice the difference between resistance in a series circuit and a resistance on a parallel circuit. Series, it was 10 plus 10 plus 10, which equals 30, right? Before it had 30 ohms of resistance, but now it has 3.3 because it's parallel. So we can conclude that a parallel circuit lowers the total resistance compared to series circuit or single resistor. So yeah, notice even if you had a single resistor, which was 10 ohms, it's less than that, 3.3, because the resistors are in parallel. So if there are more parallel resistors, that means there will be lower total resistance, and therefore, what happens if we have lower resistance? There will be higher total current, right? Higher current because there's less resistance, and therefore a brighter light bulb. So this is just a lot of cause and effect. So first, if you put more parallel, then there will be lower total and therefore higher currents. Okay. I hope everyone understands. Do you have any questions so far with these two resistors? Um, so yeah, is everything clear with the parallel and the series circuit? I will have more examples coming up, but I hope this will be able to clear up some of the confusion. So let's solve this question together. So, and everyone look at the board and the picture on the right over here. So this question asks first to calculate the effective resistance in the circuit. So how do you think we can calculate the resistance, the total resistance? Okay, first of all, what is this resistance? Is this parallel or series? What do you think?
Series.
It's actually parallel, right? If you look at parallel circuit, it's branching off, right? There's two branches. If it was a series, then there will be one resistor here and another resistor here. That would be series. But this is parallel. This resistance is in parallel. So how do you calculate the resistance in a parallel circuit? It is by this way. So can everyone see how this is done? So 1 over the total resistance equals 1 over 4 ohms and 1 over 5 ohms. If you add these, you get 9 over 20. And then at the end, remember to flip it because 9 over 20 is 1 over total resistance. So the ultimate total resistance is 20 over 9 ohms. That is how you calculate the total resistance. Yeah, is everything clear?
Yes.
Okay. Now let's calculate the current that'll flow through the circuit. I think you should be able to solve this one. Find the current, yeah. Voltage is given here to be 6 volts. The resistance is 20 over 9.
No. Right, that's fine. The next thing is really divided by resistance. This is divided by 9. See that thing? Then they go one. What time is it? It does one time. Right. Yeah, Bruce.
Yes.
Then that's 2.7.
Okay, yeah, I think you know how to solve this question, but you might be stuck a little bit in calculating. So you know that its current is V over R. So V is 6. 6 divided by what is R? It's 20 over 9. So how do you solve this? Well, this is same as 6 times 9 over 20, flipping by multiplying, and then you see, 54 over 20. And what is 54 over 20? It is 2.7 ohms. So yeah, I think you know how to solve this, but if we have like fractions of resistance like this, you should know that dividing by fraction is the same as multiplying the reciprocal the other way. So it's like this. So does everyone know how to solve this problem?
What times it is? When I'm going to don't have to money. What times I can eat? I'll do the food. Yeah. That's it. Then is here. Yeah. But things. So,
Okay. Yeah, I hope everything is clear. I hope everyone understands how I found the oops, this actually shouldn't be in this should be an ampere, sorry. The unit should be an ampere because it's a current. Okay, but other than that, that's how you calculate um the current in this circuit. You need to look at certain indicators. Okay. So I think I will move on to this next question. So if you look at this, the first question is identify the components labeled 1, 2, and 3. So here, what is this one? Does anyone know?
yeah.
What is it called? Yes, that's right. It's a cell. It's a cell. And what is this one?
Great.
Yes, that's right. It's a switch. And finally, this one, the third one.
Wow.
Yes, that's a bulb. Great job. Yeah, that's right. One is a cell, battery. Two is a switch or a key. Number three is a bulb or lamp. Okay. Number two, state the type of arrangement of resistors in B. So what would be this arrangement? Is it series or parallel for B?
I didn't know.
I like parallel circuit.
I think I heard parallel, and that is right. If you said parallel, that would be correct. Yeah, because it's arranged in, you can see that flow is going this way. There are multiple branches here spreading out. On the other hand, A, this is a series. A has series, but this is parallel in B. Okay. Now let's move on to this next question. It's the same image, but it's a different question. So number 3, state the effect of arrangement of resistors in each of the diagrams A and B on 3. So I will ask you this question. So which arrangement has more resistance? Is it series or parallel? Like more resistance.
Parallel.
More actually would be series, right? Series actually has more resistance. I'm talking about the resistance R. But you're right that parallel has more current, right? parallel has more current passing through because it has less resistance. So series has more resistance than parallel, so it has less current. So what would that effect be on the bulb? So the bulb will grow brighter in which arrangement? Will it grow brighter in series or parallel, do you think?
It's parallel.
Yes, that's right. The bulb will grow brighter in parallel. This will be brighter, very bright in parallel, very bright. But this in series will be just a little bright, only a little, only a little. It's way less brighter than parallel because parallel has less resistance to the current. Yeah, great job. So this is the explanation. You can maybe read through it. So A, the resistors are in series. This can reduce the brightness because it has less current. B, adding more resistors in parallel makes the bulb brighter because it has more current. Okay. So we already done this, part 4 too. We already did this. So we've already looked at the series increases resistance and parallel decreases resistance. Okay, great job, everyone. I will be moving on to ammeters and voltmeters. I think you might be a little confused when I said before what is an ammeter and what is a voltmeter. Remember, ammeter has this symbol. Voltmeter has this symbol, V. So ammeter measures the current in a circuit, and it tells you how much electricity is flowing. But always remember, an ammeter is connected in series with the circuit. That's how ammeters work. It should be connected in series, in the same path. But a voltmeter, on the other hand, measures the voltage across a component. Voltage measures voltage, ammeter measures current. But voltage is connected in parallel with what you want to measure. And of course, there's another meter called the ohm meter, which measures the resistance. But the main components that we're talking about are the ammeters and voltmeter. Okay. So let's answer this question. Which of the following instruments is connected in parallel across a resistor in an electrical circuit?
B.
Yes, that's right. The answer is B, because voltmeters are connected in parallel with a resistor. That is right. Let's answer this theory question with voltmeters and ammeters. So, number 1, name the measuring instrument that is in A, parallel, B, in a series with the resistor. What would be parallel? Yeah.
The A is voltmeter.
Yes, that's right. The voltmeter.
Oh,
Yeah, both of you are correct. Yeah, the voltmeter. What about B, series, the circuit?
I'm ammeter.
Yes, that is right. It's ammeter. Okay. voltmeter, and ammeter. So number 2, can you read and record the values that are on the ammeters and voltmeter over here in the picture? What does it say?
Is
Five amperes.
Yes, that is right. It's 5 ampere because 3, 4, and this will be 5. Yeah. What about voltage?
10 volts.
Oh, yes, that would be 10 volts. That's right. Because over here, it's 9 and then 10 over here. And it'll be 11 and back to 12, which is 0. Okay. And we've already talked about this. Voltmeter measures voltage, ammeter measures current. So we already did these. So yeah, great job answering these. And I think, yeah, we already know how to solve this. So you guys are good at this, right? Resistance is V over I. We use the calculated values. We see this is 5, this is 10. So it's just 10 over 5 to resistance. Okay, I'm going to skip over this one. And then, all right, let's try this one. Okay. What will be 1 and what will be the function of this number 1? Yeah, this is a cell, and do you remember what the cell does? What does the cell do?
The cell produces energy.
Oh, yes, that is right. It produces energy
What's the function? What's the cell?
to make the voltage, really. It makes the voltage by producing energy. And number 2, what about this one?
It's used to on or off.
Yeah, it's a switch that closes and opens the circuit. That's what it does. Number 3, we haven't covered this yet, but number 3 is called a capacitor. We didn't talk about this yet, but what it does is it just basically stores and releases the electrical energy. We will look at capacitor in the next slide, but does anyone remember what this one is, number 4? What does it do?
It's resistor.
Yeah, it's a resistor, right? Yeah, it's a resistor. And what does a resistor do in this situation? Yeah, it re restricts current. Yeah, that's right. The resistor restricts the amount of current that is flowing. And yeah, that is 1, 2, 3, and 4 all labeled.
Okay.
Um, yeah, let's actually go over to a capacitor now. So you might be wondering what a capacitor is. So the two
Yeah.
lines, the straight lines. A capacitor is an electronic component that stores and releases electrical energy. So basically what it does is a capacitor stores energy when it is needed. It stores actually the charge produced by the energy. So it can release energy quickly when it is needed, and it can be very useful in fast, quick energy. So let's look at this short video
Okay.
one more time. And this will show how there is.
When you shop in the Shaw's app, you can count on us to choose fresh produce, guaranteed.
You know,
So this video will show you how capacitors work. So how capacitors work. And you can see that it stores that electrical energy and releases all at once. So it is more powerful than a battery. Okay, let's look at this question. A capacitor is connected in a series circuit with LED, a battery, and a switch. When a circuit is closed, the LED, what does it do you think? Oh, we didn't quite talk about this yet, but what it does is that when a capacitor is connected, remember, it is very fast and short amount of energy. So it is like a temporary battery, but it discharges quickly. So when a capacitor is connected, then the LED flashes really, really quick. It flashes and goes off. That's because capacitor stores certain amount of energy, but releases that really, really quickly. That's why the LED flashes and then goes off when a capacitor is connected. And lastly, let's talk about fuse. So you might be wondering what a fuse was. And basically, a fuse is a safety device that protects electrical appliances from damage caused by too much current. That is what a fuse is. So fuse prevents overheating and electrical fires by breaking the current when the current becomes too high. And we have fuses in like electric kettles, electric irons, microwave oven, refrigerator, heater, etc. That's what a fuse does. It provides safety by cutting out too much current. And the last topic for today, and we will end after this, it's called the semiconductor. So a semiconductor is a material that is not a full conductor, not a full insulator. A conductor like copper lets electricity flow easily, but insulators like rubber does not let electricity flow. But semiconductor is somewhere in the middle. sometimes lets electricity flow, sometimes it doesn't. Basically, they help control electricity inside many electronic devices. And common material is like silicon. Silicon is a very common semiconductor. And also things like germanium. Silicon is the most common. Okay. So yeah, some of these parts are made out of semiconductor, things like diode, LED, transistor, solar cells are all made up of semiconductors. And let's look at this last question for today. So, does anyone know which of the following electronic components is not of semiconductors? What is not made up of semiconductor? So we looked at here.
The
All
answer is A.
these.
A.
Oh, yes, that is right. Yeah, great job. The answer is A, capacitor. Because capacitors are not made up of semiconductors. It's made up of two metal plates and an insulator. Yeah, great job. We've seen before that, yes, diode is a semiconductor made up of semiconductor, LED also, and transistor as well. So all of these are semiconductor, only the capacitor is not. Yeah, great job. And yeah, that will be the end of today's lesson. So yeah, thank you everyone for listening. And do you have any questions for me before we end today? Any questions about anything? Yeah.
Hello.
Yes, hello.
They said, yeah. All right. They said they don't have any question.
Okay. Yeah, I hope they learned a lot today. But I think next
Okay.
week, um,
So how would the next week schedule be?
how much one? So next week we will have one. So we will have a physics lesson, another one, the last part 4 of physics next week. Sorry, next week I think you have a vacation, right? So
Yeah, no, that is holiday.
a holiday.
There is a holiday on the Friday. That is on the 5th of December.
Okay.
Yeah, that is holiday. So when would that be? Would that be 4th?
Um, yes, I think next week it since there is a holiday, we will skip that week and we will meet on December 12th, I think.
Okay.
Or December 11th also works. And yeah, let me
So
know.
we're gonna meet on December 12th.
Yes, that is right.
Okay. So on the 5th and on the 4th, on the 5th there won't be class. That'll be next week.
Yes, that is right.
Oh, okay.
And I have a question for you, if that's okay. So I was
Okay.
wondering what you want to do next year after we finish physics lesson. Um, do you want to focus on agriculture or remaining science lessons or move on to like
Okay.
math? Yeah.
I'll take my time and I'll get back to you in next 2 weeks when we meet. Okay, I'll consult the rest of the teachers and I'll talk to the science madam as well. Then I'll see if you are to continue with the science, the physics, or you take the agric aspect, or if you take mathematics, then I'll communicate that to you.
Okay, yeah, please let me know in 2 weeks
Okay.
after you discuss. Yeah.
All right.
Okay.
All right. Thank you very much.
All
You
right.
can, they are still here, so you can wave them.
Bye-bye.
Yeah, thank you. Bye everyone. Yeah. Have a nice holiday next week. Yeah. Bye.
All right. Okay then. All right. So I'll wait for the slides as well.
Okay, yeah, I'll send you the slides after this meeting.
Thank you very much.
Okay. Yeah. Bye everyone. Yeah.
Bye.